So I wanted to do a very quick discussion today just on the qualities of something called the unit circle. And what the unit circle is a circle that has a unit length or radius of 1. Okay, so if this was on the axis, okay, then this would be at 1 on the x-axis, this would be 1 on the y-axis, this would be -1 on the x-axis, and this would be -1 on the y-axis. Okay, now the unit circle is pretty important for understanding sine, cos, and tan. Okay, and this unit circle actually is measured correctly with respect to the rulers on the side. Okay, it's actually like 20 units, so each one represents 0.05. Okay, so anyways, let's see here. So let's draw an angle, and we'll see what happens here. So if I were to draw an angle, okay, like this one here, okay, and it were to touch, okay, if it were to touch the unit circle at this point here, okay, well, what we could do is we could recognize that this is supposed to have an x and a y coordinate. Okay, and if we drew a line, okay, so a dashed line down to the x-axis, what we would find is that the place where it touches the x-axis, also called the x-intercept, okay, is the value of cosine theta. Okay, assuming that this is theta. Okay, now the value of the place where this touches the y-axis. So if I drew this a line, okay, all the way across, a straight line to here, okay, you would find that what would happen here is that this is where it would touch the y-axis, called the y-intercept, and this would be valued at sine theta. Okay, and what we can see then is for low values of theta, so when the angle is very small, cos is very close to 1. Okay, so in fact, when this angle is 0, okay, cosine would be equal to 1 and sine would be equal to 0. Okay, because if we drew a line back to the y-axis, it would touch it at the 0 position. And when the theta is 90 degrees, cosine would be 0. Okay, because the line would be standing straight up. Okay, it would be along the y-axis, and so it would touch the x-axis at 0, and sine theta would be 1 because it would touch the circle at the 1 position up here. Okay, so what we can see though is very clearly that as the theta gets smaller, cosine gets relatively bigger, gets closer to 1, and as this theta gets bigger, this angle would move up. Okay, so if I drew it, let's see, let's just draw it in a different color here. If I drew it like this, okay, then what you would see is that its cos value would be significantly smaller than the other one where it touches down here. Okay, however, its sine value would be very, very high. Okay, so for large angles and we're talking about only in this first quadrant here, so only within 0 to 90 degrees, sine values are relatively big when the angle is large, when it's close to 90 degrees, and cos values are large when the angle is low. Okay, so what this means though is a lot of people also ask me, well, what about tangent? Okay, now tan can also be defined as the ratio of sine divided by cos. Okay, so for small angles, okay, so I'll write it here, for small angles, okay, we'd have a very large cos, okay, a relatively large cos, so I'm going to write it big, and a relatively small sine. Okay, so what we have is a large something small divided by something very large. Okay, and what that means is we got a very small tangent. Okay, for large angles, okay, then what we would have is a very large sine divided by a relatively small cosine. Okay, so when you have something very large divided by something very small, okay, what you're going to get is something very large. So then tangent is also going to be very large. Okay, and we'll take a look at that and see if that actually is true using this calculator here. Okay, so first of all, let's take a look at cosine of 10. Okay, cosine of 10 is 0.9, and that's what we would expect. So for a very small angle here, right, we would find it should be very close to 1, and it very much is. Okay, so let's do cosine of 80. Okay, should be close to 0, and it is. Okay, similarly, if I did the sine of 10, it's very small, and the sine of 80, okay, is very high. Okay, so let's take tangent then. So if I take tangent, okay, of 10, okay, now 10, what I said is that at 10, this cosine is going to be very large, but sine is going to be very small. So we have this situation. So tan should also be very small. Okay, so let's try this. Tan, and tan is very small. Okay, keep in mind that it varies. Well, it doesn't have to be between 0 and 1 for tan, but it's close to 0, so it's actually fairly small. Okay, and at 80, okay, so for large angles, the cosine is very small, right, and the sine is very big. Okay, so the tan is also going to be very big. Okay, so let's see. So for 80 degrees, I find tangent. Okay, and tan is 5.67, so it's actually very large. Okay, so yeah, so that's pretty much how you can demonstrate this. Okay, so tan, yeah. Okay, yeah, so that's just a quick way to know about sine, cos, and tan, how they are related to each other around this unit circle, and you should be able to get an estimate for what they might be just based on the angle itself and knowing how they relate to this thing called a unit circle. In further videos, I might discuss how sine, cos, and tan work in the other 3 quadrants. So this would be quadrant 1, 2, 3, and 4. Yeah, I might talk about how they behave in 2, 3, and 4. But so far, we just need to we're just looking at how they behave in quadrant 1. Okay, once again, if you have any questions, please put a comment in the comment box or send me an email or contact me in some way. Hope you liked the video. If you do like the videos, please like it. And if you like this series of videos, please subscribe. Have a great day.